Welcome to another deep dive. This time into the world of Sir Isaac Newton.
Oh, a fascinating one.
Yeah, we've got these excerpts from a document about his life and work, and
That's interesting.
yeah, it seems like there's a lot more to this guy than just like the whole apple falling from the tree.
Right.
That story.
Classic image, yeah.
Yeah, today we'll sort of uncover the complexities of him as a person and his legacy and how really, even today his work still affects us.
Hmm,
So, really, to begin to understand all that, you have to kind of start with his childhood.
exactly.
Yeah.
Yeah, I mean, his early life, it really might have shaped his work later on.
Yeah.
Born premature, lost his father before birth, then, his mother abandoned him.
Oh, wow.
Yeah, it wasn't exactly, a happy
No,
childhood.
not idyllic.
No, not at all. And,
It's hard to even imagine, like, how that kind of upbringing would affect a kid, let alone someone who'd go on to be so massively important historically.
yeah, some historians think that this, really tough start is kind of at the root of his, reclusive personality and well, he
Ah.
was known for having some pretty intense rivalries.
Right, right. Yeah, I mean, it makes you think about, how even these brilliant minds are shaped by their early experiences.
Shaped by their environment, yeah.
Absolutely. The source mentions that when he was boarding with this apothecary family, he got really into mechanics, even built models and stuff.
Yeah, that's important, I think. Like that hands-on experimental approach, even
Right.
as a young boy,
Mm.
it kind of foreshadows his later genius for experimentation.
Yeah.
So then he goes off to Cambridge. It's 1665. Plague's going around Europe.
Right.
Cambridge University shuts down.
So he heads back home and, instead of I don't know what they did back then, there was no Netflix.
Right, right.
But he embarks on this what they call his miracle year.
Exactly.
Yeah.
Yeah, in that isolation, he makes these groundbreaking discoveries in calculus, optics, and gravity. Revolutions in science. Amazing to think about.
Yeah.
Like global crisis going on, and Newton's mind is just, making these huge leaps.
It's incredible. Let's talk about those discoveries a bit. Like, first, you've got calculus. He called it fluxions, but it wasn't just like an abstract math thing.
Right.
It provided a whole new way of talking about change and motion.
Yeah, I mean, before calculus, mathematicians really struggled to describe things like how fast is something falling at a specific moment,
Right.
or like the area of a curved shape.
Okay.
Newton's fluxions gave them the tools to do all that and more.
Hmm.
It was a revolution in how we understand, how things change and how they move.
So then there's his work on light, too. The famous prism experiments. He showed that white light is actually made up of all these different colors.
Totally changed our understanding of light and color.
Hmm.
And he wasn't just watching it happen. He was doing these meticulous experiments with prisms,
All right.
measuring angles, documenting everything so carefully.
Wow.
Remarkable for the time.
And then, of course, there's the apple, falling from the tree. Supposedly gave him the idea for universal gravitation.
Maybe the Apple story isn't even true, but I think it captures something about his genius,
Yeah.
that ability to connect something ordinary every day to these profound scientific principles.
Hmm. It's interesting, like all these different things he was studying, calculus, light, gravity,
Extremely separate, yeah.
but like in his mind, they were all connected somehow.
That's the sign of a true revolutionary thinker, I think. Seeing that underlying unity in the seeming diversity of nature.
Yeah.
But it wasn't until 1687, more than 20 years after his miracle year, that he published his big work, Philosophiae Naturalis Principia Mathematica,
Right.
or, just Principia.
Principia. Okay.
Right.
This wasn't just like a collection of his ideas.
Right.
This basically laid the groundwork for what we know as classical physics.
Yeah,
A
exactly.
major game changer.
Yeah,
But for those of us who haven't taken a physics class in a while, maybe ever, can we break down those three laws of motion?
sure, yeah. So the first one, inertia, it says, an object at rest will stay at rest,
Okay.
and an object in motion will stay in motion at the same speed and in the same direction unless something acts on it, like a force.
Okay.
Think of a soccer ball just sitting on the field.
Okay.
It won't move until someone kicks it.
Right, right. What about the second law?
Okay, the second law, you often see it written as F equals ma. Force equals mass times acceleration.
Hmm.
It's about how force, mass, and acceleration all relate.
Hmm.
Basically, the more force you apply to something, the more it'll accelerate. So if you want to kick that soccer ball farther, you got to put more force behind it.
Okay, so more force, more change in motion. Got it.
Right.
Third law.
Okay, the third law, it's all about action and reaction. For every action, there's an equal and opposite reaction. So think about jumping on a trampoline.
Okay.
You push down on the trampoline, that's the action.
Right.
The trampoline pushes back up on you, that's the reaction. And that sends you up in the air.
Oh, okay. So like every time something interacts, there are these two forces pushing in opposite directions.
Yeah, exactly. It's actually pretty simple when you think about it that way.
It is. And then, of course, you've got his law of universal gravitation. This one is a bit more cosmic, right?
It is, yeah. So this law says every object in the universe attracts every other object
Okay.
with a force that depends on how massive the objects are and how far apart they are. The bigger the objects, the stronger the attraction. The closer they are, also the stronger the pull.
So he wasn't just explaining, like, why stuff falls down.
Right.
He was explaining the motion of, like, the planets and the stars.
Exactly. This was huge. It brought together celestial mechanics, the stuff of the heavens, with what we see here on Earth,
Right.
showing that the same force that makes the apple fall is what makes the planets go around the sun. And those equations he came up with, they're elegant, simple. They're still used today.
Wow.
Scientists, engineers, they use them for everything. Spacecraft, bridges, you name it.
It's pretty mind-blowing. But here's the thing, right? Newton wasn't just like this physics and math superstar.
Right.
There's so much more to his story. He had all these other interests, some of them pretty surprising.
Oh, yeah.
And they revealed this mind that was always searching for knowledge, trying to understand everything.
That's true.
So next, we'll dive into some of that. His work with optics, his controversial views on religion, and his fascination with alchemy, of all things.
You're going to be interested. You won't want to miss it.
Stay with us. Okay, so I'm really ready to get into like these other sides of Newton. The stuff you don't usually learn about in school. Optics, alchemy, even theology. Like, it's wild to think he had this whole almost secret intellectual life going on alongside all his physics and math breakthroughs.
Yeah, it's true. And actually, looking at those other interests, it tells us a lot about how he approached knowledge, how he wanted to understand the universe like in its entirety. So
Right.
optics first. He did a lot more in that field than just those prism experiments.
Right. The reflecting telescope. Right, I was reading about that. What made it so important?
So before Newton, telescopes used lenses to magnify things. But those lenses, they cause this problem called chromatic aberration. Basically, different colors of light, they bend differently, and it makes the image blurry. Newton's solution was genius. He used mirrors instead.
Oh, okay. So he redesigned the telescope to get around this, like, fundamental limitation of the tech back then.
Exactly. His reflecting telescope, the images were so much sharper, it opened up a whole new world for astronomers. Imagine. Suddenly, they could see the stars and planets with this clarity they never had before.
Wow. It kind of makes you wonder if Newton himself even realized how huge that invention would be for the future of astronomy.
Yeah. And then he didn't just stop at building a better telescope. He had this theory about what light actually is, the corpuscular theory.
Right.
He said that light was made of these tiny, tiny particles. He called them corpuscles. Now, we know today that light acts like both a wave and a particle. But the amazing thing is, some of Newton's ideas in that corpuscular theory, even though it wasn't totally right, they kind of foreshadowed quantum mechanics, which didn't come around for centuries.
It's like he was laying the foundation for a scientific revolution he couldn't even conceive of. That's amazing. Okay, but let's move on to something even weirder.
Yeah.
Alchemy. I mean, here's the guy who basically created modern physics, Mr. Rational Scientist, and he's spending decades trying to turn lead into gold. I don't know, it just seems hard to believe.
It does seem strange now, yeah.
Yeah.
But we got to think about alchemy in the context of Newton's time. Back then, it was a respected field. It wasn't just about, making gold. It was about understanding the nature of matter itself. Remember, this was way before modern chemistry existed.
Okay, yeah. So was Newton just kind of caught up in the magical thinking of his time? Or was there something more to it?
Well, Newton, he was such a meticulous experimenter. Even in his alchemy work, you can see that analytical mind going. He kept these super detailed records, trying to find patterns, really understand how matter worked. Some people even think that his alchemy research might have influenced some of his later scientific discoveries.
It's almost like even though alchemy is outdated now, it was still part of his endless curiosity, his desire to push the boundaries of what we know.
Right.
Which brings us to another thing that seems kind of contradictory. His interest in theology. How do you, like, square the rational scientist with the religious guy?
It's such an interesting tension, right?
Yeah.
But Newton, he was a complicated guy, and
Mhm.
his faith was important to him, just as important as his science. He got deep into interpreting the Bible, studying prophecies. He even rejected the Trinity, a core belief in Christianity.
Right.
That was risky back then. It shows how independent he was, even when it came to religion.
So it's like he used the same, like, rigorous thinking, the same analysis for religion that he used for his scientific work?
Exactly. He wasn't afraid to challenge the status quo, even in matters of faith. But even with all this incredible intellectual stuff, the sources we have, they also paint a picture of a guy who wasn't, perfect. They talk about his feuds, his rivalries, how he could be pretty ruthless.
Oh, right.
I mean, yeah, Newton could be reclusive, he could hold grudges, and he was definitely very protective of his ideas.
Yeah.
He had that famous clash with Robert Hooke, another brilliant scientist. They argued about light and gravity.
Yeah, the sources even say that Newton tried to, like, erase Hooke from history after Hooke died. Is that true?
Well, it's complicated. It's definitely a controversial part of his story. After Hooke's death, Newton became the president of the Royal Society.
Hmm.
And he used that power to kind of downplay Hooke's contributions and make sure his own work got more attention. Some say he even had Hooke's portrait removed from the Royal Society.
That's kind of unsettling. You'd think genius would come with a little more, I don't know, humility, maybe.
You would think. And then there's the calculus battle with Leibniz. They both came up with calculus independently around the same time. But they had this huge feud over who deserved the credit.
The ultimate math fight. But if they both discovered it separately, why were they so at odds about it?
Egos got involved, and national pride, too. It became this fight between England backing Newton and Germany backing Leibniz.
Hmm.
It actually messed up the sharing of math ideas between those two countries for years, which is a shame. Imagine what they could have accomplished if they'd collaborated instead of competing.
It's a good reminder that even the smartest people can be driven by ego and ambition. It makes Newton seem more human, I guess. He wasn't just this scientific god, he had flaws and weaknesses like all of us.
Yeah, it does. And it makes his achievements all the more incredible considering those flaws. His contributions to science and math, they're undeniable.
Right.
And those contributions, that's what we'll look at next. We'll explore his lasting legacy and how his work still impacts our world today.
Okay, so we've seen all these sides of Newton. The genius scientist, the guy who never stopped learning, the flawed human being. But there's one more part of his life we haven't really talked about yet. His public life.
Hmm.
I mean, he wasn't exactly known for being super social,
Right.
but he did have some pretty important roles outside of, like, the academic world.
Yeah, that's right. Actually, his later years, it's interesting, he kind of shifted from like doing research by himself to these positions of authority, public service.
The sources mentioned he became, what was it, the Lucasian Professor of Mathematics at Cambridge?
Oh, yeah.
That's a big deal, right? Some really famous people held that position before him, Stephen Hawking even.
It is a big deal. And, his lectures, they were known for being super complex, even hard for some of his students to understand.
Hmm.
But having that position, it really solidified his reputation as one of the top mathematicians of his time. And his influence went way beyond Cambridge. He became president of the Royal Society, too.
Wasn't that the same place where he had all that trouble with Robert Hooke?
It was.
Well, he didn't always act in the most gentlemanly way, let's say.
That's true. And his time as president, yeah, it brought a lot of new energy to the society.
Right.
But it also showed how much he liked being in control, how sensitive he was to criticism. But the most unexpected thing he did was becoming master of the mint.
Wait, the mint, like where they make money?
Yeah.
It seems so different from, like, figuring out the laws of the universe to, like, overseeing coin production.
It does. But in 1696, he was appointed warden and then master of the Royal Mint.
Mm-hmm.
It wasn't just a title. He was in charge of this huge project, the Great Recoinage. They had to replace all of England's old, messed up money with new, standardized coins. And you know what's interesting? Even in this job, you see his brilliance, how detail-oriented he was. He came up with all these new techniques to fight counterfeiting, like putting milled edges on the coins to stop people from clipping them, which was a big problem back then.
So, like, from defining how motion works to protecting the country's money, Newton's mind and his drive, they left a mark on so many different things.
Right.
And then, in 1705, Queen Anne knighted him, Sir Isaac Newton.
Hmm.
That title, it recognized not just his science, but all he did for public service, too.
Yeah, it really shows how wide-reaching his impact was on English society.
Yeah.
But like we've been talking about, Newton's story isn't just about amazing discoveries and awards. He was complicated. He had flaws and contradictions.
Definitely. Yeah, he was brilliant, but he could be hard to deal with. He got into rivalries. He was so defensive of his ideas. How he treated Robert Hooke, that whole thing with Leibniz, it shows us that being a genius doesn't automatically make you a good person. But I think it's important to talk about those flaws, not to take away from what he accomplished, but to see him as a whole person.
I agree. Knowing his complexities, it makes his story even more interesting. It reminds us that even the greatest minds, they're not perfect. They have the same human emotions, the same weaknesses as the rest of us.
So, after all this deep dive into his life, his work, what do you think is the most important part of Newton's legacy? Why should people today, centuries later, still care about him and what he did?
To me, it's that endless curiosity he had, his drive to understand the universe, and his bravery to challenge what everyone thought they knew.
Hmm.
He wasn't afraid to question, to experiment, to go beyond the limits of knowledge. His legacy isn't just the things he discovered. It's that spirit of asking why and searching for answers, even if those answers take you to unexpected places.
That's powerful. It makes you wonder what he'd be working on if you were alive today.
Yeah,
With all the challenges we face now in the 21st century, what would he be focused on?
it's a great question. Maybe he'd be trying to solve the mysteries of dark matter and dark energy.
Hmm.
Maybe he'd be at the cutting edge of artificial intelligence or quantum computing. Or, with how fascinated he was by changing matter, maybe he'd be into nanotechnology or genetic engineering.
Who knows? Maybe there's another Newton out there right now, a hidden genius working in something we wouldn't even think of as science today, like how alchemy was back then. Someone with that same unstoppable curiosity, that need to uncover the secrets of the universe.
That's the beauty of science and knowledge. It's this never-ending journey of discovery. In Newton's story, it's like a powerful reminder to keep exploring, keep asking questions, never stop looking for answers.
That's a great way to put it. And on that note, we'll wrap up our deep dive into the world of Sir Isaac Newton. A big thank you to our expert for taking us on this incredible journey. And to our listeners, keep exploring, keep questioning, and who knows, maybe you'll be the one to make the next big breakthrough. Just watch out for those falling apples.